Alright, so the last thing was 3.3, which was shapes of graphs and average rate of change. Okay, since I'm short on time and how much space I have on the flip camera, I'm going to try to go through this quickly. So here's a picture. You should know the vocabulary turning points, increasing, decreasing, maximum, and minimum. Okay? Let's start with turning points. A turning point is anywhere on the graph where the graph changes from going down to now going up, or from going up to going down. In other words, it turns around and goes the other direction. So if I follow the graph here, at 6 it looks like I'm decreasing, decreasing, decreasing until I get to 5, and then it turns around and starts increasing. So we would say that we have a turning point at 5, looks like 5,3 there. So a turning point at 5,3, and then it looks like now I'm increasing, 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 and then at 8,12, another turning point, turns back around and starts decreasing, decreasing until I get to 10,6, and then after that it looks like it's increasing for the rest of the function. So we have 3 turning points there, 5,3, 8,12, and 10,6. And since we talked about increasing and decreasing already, okay, we say that from 6, well not 6, here x is 0. So from 0 to 5, my graph started at 6 and went down to 3. So from x equals 0 to 5, we say it's decreasing. So the interval 0, 5 is one of the intervals where it's decreasing. And let's finish the decreasing. At 5 and up to 8, looks like I'm going up. But from 8 to 10, my function is decreasing. So I'll just list it. You don't have to use unions here. We're just listing intervals. So from 8 to 10, we are decreasing. Okay? And now increasing, well, from here, from 5 to 8, my graph is going up. So from 5 to 8, my graph is going up. It goes down afterwards until we get to x equals 10, but then after x equals 10, it looks like it increases the rest of the way. So from 10 to infinity would be increasing. Alright, so now max and min. This particular graph, you guys know how to find max and mins already. You can use the calculator. You could certainly use the graph if you've got it in front of you. Since we don't know what the rule is for this, we'll just look at the picture. It looks like there is a minimum value right here at 5,3. So when we're asked what is the minimum, you're looking for the output. What's the smallest output of this function? Okay, the smallest output is 3. Okay, it never gets any lower than 3. Maximum means highest output. Well, it looks like this might be 1, but then afterwards it keeps going on forever. So we're going to say that there is no max, no maximum. Okay, unless for some reason I erased this and didn't have that there, then I would say maybe that my maximum is at 12, because the highest that it gets is 12. Okay, so there's the shapes of graphs with the right vocabulary. We talked about max, min, turning point, increasing, decreasing. I think we're good. So now average rate of change is essentially slope. That's all it is. Okay, so if you have a graph that looks something like this, let's say here's A, here's B, and here we're at, let's make it a little bit more interesting, sorry. So here we're at a point, and then here we're at a point. Okay? You know that the slope is not always constant. If it were constant, this would be a straight line. So here my slope is positive. It looks like it starts to decrease here. So I can't really say that this has the same slope throughout. But what we can do is connect these 2 points and find an average slope, which is the average rate of change. So to do that, you simply plug in the coordinates x and y, x and y. So let's say this is f of x. And if this is where x equals a, then your x coordinate is a. Your y coordinate would simply be f of a. It's the output that you get when you plug in a. The coordinate for this point would be b, and then f of b. Okay? So what's the average rate of change? You guys already know it. It's just the slope formula, y2 minus y1 over x2 minus x1. So you do f of b minus f of a. That's the change in y. y2 minus y1, right? y2 minus y1 over x2 minus x1, b minus a. This is the average rate of change formula. Don't forget it. It's very important. You need to know it from here for the rest of pre-calc. Okay? So how does this formula work? Well, if I give you a function like f of x equals x squared minus 9x, okay, and I said find the average rate of change on the interval from 1 to 2, okay, you don't even have to graph and connect the lines. If this is x, this is where x equals 1, this is where x equals 2, you simply just find the outputs. Those go in the numerator, so you're going to do f of 2 minus f of 1, and then you do 2 minus 1, okay? So it's just following the formula. This is your a, this is your b. So you do f of b minus f of a over 2 minus 1. So what does f of 2 mean? Well, f of 2 means take 2, plug it into x, figure it out. You're going to get 2 squared minus 9 times 2, okay, minus, now f of 1 means take 1, plug it in, so you get 1 squared minus 9 times 1, which is 9, and divide it by 2 minus 1. So after that, you just simplify. 2 squared is 4, minus 9 times 2, so 18, minus, and then here we have 1 minus 9, which is negative 8, and that's all over 2 minus 1, which is 1. Simplify the numerator, and if I'm off the board a little bit, I apologize, but essentially it's, let's see, 4 plus 8 is 12, and then we're going 12 minus 18 is negative 6 over 1, so the answer, if I've done it correctly, is negative 6. Okay, so there's the average rate of change. Now, with that, we have difference quotients. So let's see if I can sneak those in here. They look something like this. F of x minus f of a over x minus a. Or f of x plus h minus f of x over h. Okay, this is one type of difference quotient you need to know how to simplify. This is another one. Well, guess what? These difference quotients are essentially average rates of change as well. Okay, you don't need to know that, but in case you wanted to figure it out, if you use the average rate of change formula and go from a to x, and I erased it, but f of b minus f of a over b minus a, you plug in your a, you plug in your b, guess what? You get this. Okay? And if you did the average rate of change from x to x plus h, this is the exact same formula that you would get. Okay, so if you want to verify those on your own, feel free. Otherwise, what I'll do is an example. Let's just keep f of x, what was it? F of x, I think, was x squared minus 3x. No, I think it was 9x. Okay, so let's use that function that I used before when I did average rate of change from 1 to 2, and let's see what happens. Okay, so what will the problems look like? It'll say, here's f of x. So if f of x is equal to this rule right here, find this thing. Find this difference quotient. Simplify it. What does it look like? Well, all you're going to do is plug in your input. Here my input is x, so I don't do anything to it. Here's f of x. Here my input changes to a, so I plug in a. You get a squared minus 9a. Okay? And then the bottom is x minus a. There's no f in front, so I'm not plugging it into anywhere. Now you simplify. Okay, so you're going to have x squared. And just to make things easy, you'll see why in a minute, I'm going to put x squared minus a squared together. And I'm going to put my minus 9x, and if I distribute the negative, it'll be plus 9a together. Okay, so x squared minus a squared goes right here. Negative 9x minus negative 9a is positive 9a, so there it is. And now you can see that if you wanted to simplify this, you can try to group, but that's not going to work exactly the way you would hope it would. But you can kind of factor the first half with difference of squares, x minus a, x plus a. And then here, if you take out negative 9, you get x minus a as well. We leave the denominator unchanged for now. And now you'll see, oh look, my first term has an x minus a, my second term has an x minus a. I'm going to take out x minus a and put it in front. And then what's left over? I'd have x plus a minus 9. And that's all over x minus a. And now since this is multiplying this, I can cancel x minus a with the denominator, which is identical, and my answer would be x plus a minus 9. So if I simplified this difference quotient, my answer is x plus a minus 9. Okay? We can repeat the problem. I'll do the other difference quotient. See if I can sneak it in here, which is f of x plus h minus f of x all over h. So now what is that going to look like?